is, of course, very excited to start building this LLM application. And she, just mails back them and say, okay, how do I get access to the data and so on. And she gets access to the data and she and her team start building this LLM model, right? And as they start building the LLM model, they realize that, oh, the model is not doing a great job. And as they further debug, they realize that the data has a lot of challenges. And this leads to weeks and weeks of rigorous effort, ultimately leading to a hard time for the team setting in on why the model is not working well, and they iteratively finding data quality challenges in the data and so on. So again, I think this is This is not a one-off story. This is not a new story. This is a story that is experienced by a lot of data scientists. And everything that we discuss in the talk today is going to help avoid such scenarios. So let's make this more concrete on what we are talking about. So let's take an example scenario. Like we said, what was Preeti's goal? I want to make a code LLM awesome at VHDL, right? VHDL is one of the programming languages. So the first question that a user would ask is, okay, let me just take a code LLM. And if you're not aware with code LLMs, there are lots of code LLMs that are present. These are large language models that can be used for generating code. And for example, if you click on the link below, it will take you to the Granite models on Hugging Face, which are open source models, and one can use them to generate code, right? So the first thing someone would do is, if you were in Preeti's place, you would do is, okay, go to the Granite models on Hugging Face and get the models and try out for a few queries on how it performs for VHDL language. Okay, if the performance is satisfactory, actually, then there's nothing more to be done. But more often than not, for languages which are not very popular, the performance may not be satisfactory. And then the model needs to be fine-tuned with VHDL data, right? So if you show the model more of the data on which the language that you wanted to perform well, the model is likely to perform or do a better job. So what would be the steps here, right? How would Preeti and team go about building a solution like this? So first, they have to acquire the right data. In our scenario, remember, Preeti requested the organizers to send her more data. So she basically got a list of 5,000 GitHub repositories that contains VHDL code, right? So that is the data. Okay, so step one, now we have gotten the data. Great. Second, if you look at, you must all be familiar with GitHub repositories. And as you might know, GitHub repository, when you download a repository, you basically get a .zip file. Now, a model cannot accept a .zip file as an input. So the data has to be prepared, has to be put into the right format. It has to, undergo several data preparation and quality analysis, which is a bunch of steps. So that is, the next steps that Preeti and team would do. Then they would tokenize the model, right? And then fine-tune the model. Fine-tuning a model basically means that now showing all of your VHDL data, put them back into the model and continue model training so that the model gets better at VHDL. Validate the model and iterate. So as you can see in the loop here, what would happen is that as the user goes through these steps, right, of data acquisition, preparation, model tuning, validation, and at some point of time after the validation, the question they want to ask themselves is, okay, does the model that I have trained, does it meet my needs, right? Are the numbers on accuracy, are they good enough? If they are, then I think the cycle stops here. But more often than not, then in a single cycle, you may not reach the performance that you care about. So a user may have to go back and say, okay, the model is doing really bad for certain set of libraries. Okay, maybe I need to go and acquire more data. Or a user may say, okay, there were many data challenges. Maybe I need to go and do more of data preparation and quality analysis. And thereby, this is an iterative cycle, which makes the whole process of data preparation for large language model application very cumbersome. It's time consuming and it's tiring, right? So remember our friend Preeti, who was trying to do this for many, many weeks and was not making progress at the rate at which he expected to make progress, right? The point with the slide is that, right, the nature, data is the first step while building any LLM application. And it's not a linear cycle. It's basically an iterative cycle. And because of the iterative nature, this is a cumbersome, time-consuming, and a tiring task, right? And there have been studies that have been performed by Gartner, which say that 79% of people identify data preparation and generation as the most common strategic task performed by AI teams. Now, that should tell you how important is data preparation for large language model applications. And the reason for this is very simple. Why is this such a staggering high number? The reason is very simple because of this very simple concept of garbage in, garbage out. If you give in high quality data to the model, you get a high quality model. You give in, bad data, the model will not do as well, right? Very simple concept, garbage in, garbage out. And during their study, they had also found that 30% of the people viewed data volume and complexity as one of the most challenging aspects of AI implementation. So in this talk today, we are going to help you learn and navigate through some of these challenges that you will face in the data space while you're trying to build the large language model applications, right? So bottom line again is that the quality of data affects the quality of the model, and you want high quality data. Okay, so we've spoken about the importance of data. Now let me, I think, put all of this into perspective of what a large language model development life cycle looks like. Where does data preparation fit in, and what can be done about this? So as you can see on the screen here, right, the first step is data ingestion. Remember our friend Preeti, who wanted to fine-tune the model on VHDL as a language. So her starting point was where her customer came back and said, okay, here are these 4,000 repos which contain a lot of code for VHDL. Okay, great. Now that the data ingestion is done, right? Okay, someone has to go and crawl and get all of these 4,000 repos. Like I said, when you download a repository, you get a .zip file. A model cannot take the .zip file as input. So the next step is data standardization. Okay, can we put all these data together in a standard seamless format so that a model can actually ingest and utilize this data? The third pillar that you see here is around data preparation. So as you have now acquired your data, so remember the 4,000 repos that we got, which has, and each repository has a large number of code files. So that is the input data that we have. Now this data is standardized, which means it has been put into a file format that the LLM, that can be used to ingest data into the LLM. And then the next step is around data preparation. And remember, we said that data preparation was iterative and time-consuming and cumbersome because you don't know upfront what are all the challenges that your data has, right? And the solution that we as a group have come up with, right, is that instead of trying to do it iteratively, we want to build a data preparation toolkit which contains a large number of data quality checks. So as you get your data goes through all the possible data preparation checks, thereby you enhance your chances of getting high quality data in your first pass instead of having to do cycles, right? So that's the data preparation block, which contains many different steps like deduplication of data, data quality filtering, detection of hate, abuse, profanity, license filtering, and many more steps, right, which we will be discussing in detail in this talk, right? And once the data is prepared, right, you want to tokenize the data, and then one can, decide to use the tokenized data for variety of model training, right? So in our example, for our friend Preeti, she was trying to fine-tune the LLM. Fine-tuning an LLM means basically fine-tuning can have many flavors. one of the flavors of fine-tuning an LLM could mean that you take a base model, which is a pre-trained model, and you would show it additional data for your use case of interest, and you continue training the model. That is one of the ways in which fine-tuning can be done, which is what our friend Preeti was trying to do. But a user could also say, hey, I am interested in instruct tuning a model, or I am interested in building a retrieval augmented generation application. These are all possible ways of model training. To keep it simple, for our discussion, we will be coming back to this example of fine tuning. But all the data preparation techniques that we use, right, could be applicable across the board. Okay, so again, right, the point that we've tried to make here is that if one could do exhaustive data quality evaluation at the start of the life cycle, it just makes it very easy to produce high quality data, and thereby making your whole data life cycle really, really simple. Okay, now if great, I think so. We all agree that we want to do data preparation as one of the early steps, and that is fantastic. But what are some challenges, right, for data preparation, right? And a lot of the challenges that we talk about throughout this talk will be for code data sets, which I believe, right, that everyone, all the students write code, so you guys will be able to relate to it better, right? So if you think about data preparation challenges, right, one, you don't know what challenges are there in the data. That's the biggest challenge, right? So remember Preeti, she got access to 4,000 repositories, and that was the data that was given to her, right? And then she could crawl and get 4,000 repositories, but she has no idea of what are the problems that are there in the data. So that is, I think, one of the biggest challenges, which means that one has to go and discover the data preparation challenges, which is why it becomes cumbersome and time consuming. Second is every use case has its own unique needs, right? We have been discussing an example scenario where Preeti wants to build a large language model which will do great job on VHDL language. Someone may want to build a large language model which does great on a different language, say FoxPro, or a third language, and so on. So every use case comes with its own unique needs, because now, as you see, right, we have moved from different programming languages. We were talking about VHDL. Now, then we were talking about FoxPro. Then someone may want to make the large language model great and write a lot of awesome SQL code, right? So every use case is different. And also, if your data is think about 4,000 repository, and think about roughly you have about 50 to 75 files per repository, and every file has about 100 to 200 lines of code. You could do the math, right? The number of data points that you have is large, and manual verification is not possible if the size of the data is large, right? So how do you even figure out where your problems are? And then, we have been discussing so far in Preeti's use case where she wants to improve a code large language model. But you could also think about a natural language large language model, right? I'm sure all of you must be familiar with ChatGPT, right? Or the recent large language models that are coming out in WhatsApp, right? Now they work on a different modality, which is a natural language data. So the point is that data prep steps, right, they are different for natural language versus the code modality, again, making it like a harder problem. And I think, and the biggest challenge is that there are not easily available tools to solve all these data challenges at various scales, right? So, for example, Preeti had 4,000 repositories, maybe had 10 GB of data. Another person who's trying to build a large language model for SQL could have, let's say, 10,000 repositories leading to 50 gigs of data, right? So as the scale of the data changes, one has to think through all the challenges associated with large scale data processing, right? Because now you cannot do in-memory data processing. You cannot use your standard pandas and the very popular data frames because you're not going to be able to read all this on the memory. So you have to think about other kind of architectures like Ray and Spark to process this kind of data at scale. And in industry, people have there's a need for low code or no code automation so that for production scenarios, people don't have to write a lot of code to prepare their data, right? So these are the various challenges that we've spoken about. Let's go further and see how, what is the solution or what can be done to avoid these challenges. So we want to introduce data prep kit to you that contains data preparation recipes for code and language modalities. These are recipes that our team at IBM Research has built, and they have been well tested because they have been utilized in our own large language models, which is the Granite code models. And these recipes can be used for fine-tuning, RAG, or instruct tuning use cases. Data prep kit allows a user to run it. So you can run it on your laptop. You can just go to this page. You can do a fork. You can try to get you can try to get it on your laptop. And if your data size is small, you can just, use your laptop. But like I said, different use cases have different sizes of data. So if your data size is large and maybe you want to run on a cluster, then this toolkit allows you to do all of that, as it has, it supports Python runtime, Ray runtime, Spark runtime, and so on, right? And again, this is an open source project. So I'm very excited to talk to, all of you students about this because, open source, this is a way by which, you can, this is not something that a set of researchers are building in their labs and environment. We are building this along with everyone in the open source community. And as students, this could be your opportunity to learn and understand how open source projects work and contribute and thereby also gain skills, but also be part of this, large mission of pushing the state of the art of research and development in this, very, very fast growing field. Okay, so let me give a quick view of what are the data preparation modules that are there. And we will go into the details of each of these modules so that you can understand and appreciate what data preparation does for each of the steps. And like I said, in the upcoming hands-on sessions, we will take you through hands-on exercises by which you will be able to run this on your own, right? So what you can see here on the screen is here are the different modules that are possible. So they vary from data ingestion. So data ingestion is essentially, being able to take in the data. We spoke about code as an example, which so if you go and download a GitHub repository, you get a .zip file. So we have you can use a code to Parquet, so .zip to Parquet, which will take your .zip files, convert it into Parquet. Parquet is a file format that has been used, that will be used across the data prep kit for storing the data and processing the data. But hey, if you are not working on code LLMs and if you're using natural language data, maybe you have files which are in PDF or maybe you have files in HTML and they could be converted to Parquet. The next section that you can see are transforms, right? So these are universal transforms, language-only transforms, or code-only transforms. So universal transforms are the transforms that are applicable to both code and language data, and code-only or language-only transforms are meaningful only for a certain kind of a data modality. Interesting transforms in this area are, exact deduplication, fuzzy deduplication, profiling of the data, resizing of the data, filtering the data. Language-only transforms are finding the quality of a document, document chunking if you're trying to build a retrieval augmented generation application, text encoders, if you have made the chunks for RAG applications, how do you convert them into embeddings? PII detection and redaction. For code only, you have programming language annotations, code quality annotations, malware, header cleanser, semantic file ordering, etc. Right. So basically, as you can see, this field is very vast, and I can also say that this is in no ways all the transforms or all the data preparation steps that one can think about, right? And new research is being done every single day to bring in more transforms, more modules, so that the data, we can get more and more higher quality data. Now, one interesting thing to note is that you can see that these are available across variety of runtimes, Python only, Ray, Spark, or KFP on Ray. KFP is Kubeflow pipelines. And the whole idea is very simple, right? That if your data is small, then you want to maybe use just the Python only version, be able to just run it on your laptop and get done with it. Or if you have large scale data, you probably want to use Ray or Spark or one of those to be able to run your data at scale. You could also use Ray Local to still run it on your laptop and get still get reasonable parallelism, right? Okay, so this is, I think, maybe a good point for us to stop for a bit before I invite my colleague Shailaja to talk about the state-of-the-art data preparation techniques. Maybe this is a good point for us to stop here and take questions if there are any.
Any questions, participants? You can raise your hand. Or we can continue, Hima. 1 second. No? Somebody is raised. Okay, no. Yeah, you can continue. We will take questions at the end.
Okay, perfect. Okay, so with that, I invite my colleague Shailaja to take us through the various data preparation techniques in detail that I think we just did an overview of. Over to you, Shailaja. Shailaja, we don't seem to hear you in case you're talking.
Shailaja, are you able to unmute? You should be able to unmute now.
Am I audible now?
Yeah.
Okay, great.
Yeah, just give me a second, Shailaja.
Yeah.
Varuna, do you have any question? Varuna, I've asked you to unmute yourself to be unmuted. Varuna, do you have any question? Okay. Yeah, please go ahead, Shailaja.
Thank you, Dr. Sujata. Thanks, Hima, for setting the stage and talking about all the advantages and problems with the data set that we have. Now let's dig a little deeper into what are the specific methods that have been used for preparing data. So before I dive deeper, let's just talk about dataset and why is it really crucial. So we all are talking about language models, and one of the key factors that is important in or has been seen as important in progressing towards text and code task with respect to language models has been the presence of a large amount of data set. Now, that is one aspect. Now, second aspect is when we are talking about language models, we are also talking about gigantic language models, meaning they are not like very classical machine learning models, which has like 15 or 20 number of parameters that it needs to learn. We are really talking about billions and millions of parameters that these models have that needs to be learned. So when we are talking about language models, one of the major challenges that comes is the problem of memorization. So yes, dataset really helps or has helped these language models at performing great many tasks. But at the same time, it has also been seen that these models memorize a lot of the things that it sees in those data sets. Now, this problem only grows as the number and amount of data set that we are showing to these models. So now there are a lot of issues that happens as we could imagine when either we memorize something or if our model is just memorizing something or not understanding those. And that is one thing, but that we will talk about. But another thing that you can think is when we are showing these large amount of data sets, it is not just that these problems are there with respect to these models, but processing this data set is also expensive and it is not possible to do it in manual sense. So one of the major issues that comes or one of the major biases that these models develops of this huge amount of data set is the repetition of the data, for example, examples that are there in the data set. Now, what happens if there is duplicate number of examples in that data set that we show to this model? A lot of problems like appear if you show a lot of repetitive examples in those data set. And as you can see, the memorization is one of the major problems that we talked about. And these are all the plots. These are coming from some of the studies that have happened, all of which points towards the fact that the more the number of repeated examples that are there in those data set, the more parroting or memorization these models do. And those memorization happen in various forms, which is that the larger the model is, the more it mimics. Second, the more the repetitive examples you show it, the more it mimics. And the longer the length of these examples are, the more the model mimics. And mimicking here literally means that it just parrots whatever it sees. And why is this a problem? We will talk about why is that a problem, but first I want to show you through some of the studies which shows that yes, this is really a problem. The data set that we are showing to these models, there are lots and lots of repeated data, and which is really resulting in memorization. So this is another study which shows that one of the largest data set, which is there in the open domain, it is called Open Web Text and C4 data set. All of these are web crawled pages. So you can imagine they would have a lot of categories of examples in those. So all of those are binned into several bins in these plots. And what you see on the y-axis is the number of repeated examples or duplicate examples within those tasks that are seen in those training data set. Now, what is the impact of these? I'm talking about a lot about these duplicate examples or repeated examples. What is the impact of this? So the problem that, the problem that is immediately visible due to these duplicates are that the more the number of duplicates are there, the more they are weighted when they are shown to these models. So what happens is the model will really get biased toward these repeated number of examples and will speak volume with respect to these examples. And what happens is model will really show good validation accuracy on these tasks because it has seen so many of these that it knows how to memorize those examples really well. And those are immediately visible in these large publicly available data sets. So there is this study that shows that the C4 publicly available data set, it has about 3% of memorized or repeated examples, which is equivalent to about 10 million documents. And you can imagine that what kind of memorization that would be resulting in the model that would be trained on this kind of data set. Okay, so next here we are again talking about all of the implications of the repetitions or duplications that are there. So this is another study that shows that, okay, so you can also imagine that these language models, how do you interact with them? You pass in some input in the form of question or in the form of incomplete sentence that these models have to complete or answer, right? So you have an input and you have an output. But even in case when there is no input and you are just trying to generate a lot of text from these models, in those cases also it has been seen that it is emitting about 1% of the outputs that are there are basically memorized, or I would say it has literally just copied from the training data set. And it has also been seen that there was some 61 word length sequence, which was repeated about 61,000 times in the training data and about 61 times in the validation data. So when it is repeating in the validation set, you would imagine that when you are actually calculating the loss on the validation, that would go really high because it has already seen those examples in the data set, which is not good, right? Like, because you are not actually validating or assessing the quality, quality of the model. You're just it's basically cheating those examples. So that's what it is saying. Finally, if you have repeated data in your training data, and if you remove those repetitions, what would it result in? It would result in reduction in the amount of data set, which will eventually all help you in training your models faster because you have less number of data sets. So these are some of the impacts of having repeated or duplicate examples, and what are the immediate advantages. Now let's talk about, duplications happening in the training data set. Now, okay, so how can we deduplicate those, or how can we remove those repeated samples? So there have been state-of-the-art methods which are really derived from the existing body of the literature for identifying string similarity. And so I will be talking about two methods in broad here. The first one is the exact substring match. Now, if you have, let's say, a data set that comprises of a set of examples, and each example is a sequence of tokens, or you can say sequence of words. And now suppose you have two samples which are repeated, or one sample is a repetition of the other, then one way you can find that they are duplicates of each other is that you literally look at the similarity between the two. And how would you look at the similarity between the two? If there can be the case that there are certain examples that are really long in length. If you keep on looking at the similarity between the two for all of the different lengths of the examples, it can become cumbersome. So typically what people do is people look at substrings of those strings, which are exactly similar of each other. So the substring can be a smaller length substring of that complete string. And in literature, people have used a substring length of typically 50, which has really worked well at identifying duplicates or repeated examples. Now, if you look at this method where you have one repeated example and of one of the samples that is there in the training data, you would be able to identify whether this given repeated example is present in the training data in no less than quadratic time. Because if the number of examples that you have in your training data is n, and if the length of the string that you have in your hand is b, then you will have to literally search for all of those entire length of the string in your training data set, and it would be about n cross p. So this is not efficient, especially if you have a really large data set. So there have been immediate improvements in the exact substring method, where people have tried to develop what is called suffix array. And developing this suffix array means you will have to first develop a single string, which is a concatenation of everything that would be present in the input sample. Now, once you have this string, you can transform it into a suffix array by taking the suffix, by taking all of the suffix of the string that you have in front. So this is an example suffix array for this example string that you have in front of you. Now, once you have the suffixes developed, you can just club them all together into a sorted list of like in the form of an array with a sorted list. And each of these entries are assigned an integer value just for the ease of indexing into those. Now, forming the suffix array is happening in linear time. Once you have this array formed, it's then easier to apply a search on top of it, which will be taking like a binary search cost. So this entire duplication finding method will not go beyond the length of your repeated sample times log n, which is the search cost that you will have in front. Okay, now we talked about exact substring matching method, which helps us identify duplicate examples in our training data set. Now, imagine you have a example and a repeated example of that particular example in the form such as this, where one example is doing a comparison on the programming language Rust in the if condition, if you see here, and in the other duplicated example of this logic, you see that the comparison is happening on JavaScript. But other than this line, everything else is, or the logic is exactly similar. So they are duplicates, but the exact substring method will not be able to identify this. Why? Because of the differences in the identifiers, names, or variables that you will be using in different instances of your same logic. So how can we identify such duplicates where there is a significant overlap, but they won't be caught by exact substring method? So there is this another method which is called near duplicate algorithm. And this works on identifying an approximation with respect to the overlap that exists between the similar examples. And this happens by first taking the hashing, by relying on hashing technique that take the hashes of those examples. Once you have the hashing, you can then apply any of the similarity methods on top of that. Typically used is Jacquard's similarity method. That what it does is it takes the intersection with respect to the two examples to the union of everything that appear with respect to those two examples. And the higher the score with respect to the Jacquard similarity, the more is the match with respect to those two examples. Now, again, the problem with this method is it can run into a quadratic cost if you have large number of examples, and if you do not apply the hashing on just a smaller subset of the string, but you go to the entire string length. Now, a lot of improvisations has been done with respect to those. One of them is, once you would have applied the min hashing technique on your examples, the next step is take what is called locality sensitive hashing. So first step is apply the hashing, and in the next step, group those hash or the signatures of the examples into clusters or groups which are similar to one another. So in this way, you are reducing the number of queries that you will have to apply to find the similar strings that are closer to one another. And how that happens is basically there are two things that that is done here. One is called band and another is called rows. So once you would have applied hashes to the examples, you structure them into a tabular format, and you split them into rows and bands. So a band will only have certain number of hashes. So when I'm saying certain number of hashes, when you're applying a hashing to an example, you will not just apply the hashing once. And why am I saying that is because there can be two examples which can have the same hash, because there is a collision, there is a chance of collision that can happen. So what is the good way to have a unique signature with respect to these hashes, yet they don't collide for different examples? That can happen if you take different permutations of a hash and generate a longer hash as a signature for a particular example. Or another way of generating this signature is by using different hashing functions and apply them on a signature, so you have a longer length hash. This is same as saying that if you have some image and you take its embedding representation, and if you take very high dimensional representation, you have a very unique signature. It's the same way of saying it. Now, once you have these hashes for the examples, you kind of bucket them in the form of bands, and each of these bands will have equal number of rows. So if a certain part of the hash is kind of matching for 2 or 3 examples, which are all falling in the same band, then they will be considered as duplicates of each other. I will show that in the form of example, but once you would have taken formed them into partition and you have those groups, you can further look at how close or how probable is the fact that they are a match of each other by further going ahead and picking those examples from those bands or those groups, and then validating them by taking the Jaccard similarity over that and then calculating the probability. Now, to further make sure that, the examples that you are saying that are similar to one another, and to verify it further, you can also look at their edit distances, which can be a Levenshtein distance, which is a string similarity measure. And again, you would look at a threshold, and if that threshold is only higher, then you would consider that, okay, now finally I can say that these two examples are similar or duplicates of each other, and we can go ahead and filter those out. And then there are other techniques that you can apply on top of this. That is, once you would have found the similar examples, you can again form a graph of those similar documents together. And any documents that are close to each other, there will be an edge between those. Once you would have formed the graph, you can also take further steps, as in taking some kind of ensemble or doing a forest thing and taking a top K score as on top of those graph elements, and saying like adding further level of validations for getting similar documents. Okay, so this is just an example of what I was iterating previously. So if you have let's say a statement which is duplication is so much fun, that is the complete statement, and now it has been broken into n grams here, as you can see, which is 3 grams, on which the hashing is applied. Now, once the hashing is applied, and here we are applying 5-way hashing, meaning that we are applying 5 permutations of the hashes to get a signature that is of this length. Now, once you have the hashes applied to these examples, the next step is, as I said, there is a band and row, 2 factors. So for each of these band, you will have equal number of rows, which is 2, and then the hashes are also split across the band. So in this case, you have 2 hashes per band. Now, in the next step, you would go ahead and in each of these bands, you would look at which of the examples are similar to each other by applying the Jaccard and having a threshold set, and only those which crosses that threshold, you take it further and apply the edit similarity. So these are the steps that you apply in sequence, or you can apply them in parallel, depending on how much validation or how much how much confidence do you really want in your method when you are actually finding the duplicate examples. Okay, so far I gave you an overview of what other methods that we are using in finding repeated examples in the data set. Another major problem that is percolating even more now is called data contamination. And what exactly is data contamination? It is when you see, so ideally, how do we train our models? We have a training data set and we have a test data set. So once we have trained our model, we have a test set on which we check how good our model is. But we can't mix these two data sets, right? So contamination is when your test set examples appear in your training set examples. And that is called contamination. And there is a need for decontaminating those training data set. And why is that the case? Because as I talked about previously, so the more you would see test or validation examples in your training set, there will be a higher boost in the accuracy in your model because they have already cheated, because they have already seen your test examples. So they will perform really good on your test examples. But that is not really the case. The model was not fairly tested, so it is very biased. And there are two types of contaminations that have been observed in the language models. One is when the inputs and the outputs for a particular example, both of them are present in your training set. So for example, the question that you will query with and the answer that is there for that query. So for example, if your question is implement an adder, and there is a response which is a logic of that adder. If both of these are present in your training set, this is called input-output contamination. But if only the questions or the inputs are present in your data set or training set, that is called input contamination. And both of them harm or hurt the model's capabilities. Now, why does this contamination happens? Now, this we can think of as, okay, the majority of the data set that we have in the public domain, which are like we can talk about the ones that we saw, open web text or C4 in the previous slides, all of them are developed by crawling these web pages from the internet. And it is also possible that our test sets, we would have at some point in time uploaded them in some of our GitHub repositories, right? The moment we do that, and they would be scraped off when the training set was prepared at some point in time by somebody, it would appear in the training set in some form or the other, and which is how literally these test sets percolates in the training set. So how can we avoid this? This is definitely not good because our models are getting biased. They are not showing us the fair comparisons, as well as they are not learning well because they're not generalizing well. They're just mimicking what we are showing them. So how can we address this issue? So some of the methods that have been taken in the literature for addressing this issue is very similar to how we deduplicate our training data set, which is that you would at least first find out the matches, right? So if you have an example from your test set that you want to see a match against in the training set, you would want to see how similar those examples are. So there are two ways it is done. First is surface level similarity assessment, which you would do in a fuzzy manner, which is that you would look at approximate matches that are there, for which you can use an edit distance-based scoring. It can be a Jaccard similarity scoring. It can be Lavenstein scoring, whichever you prefer. That would give you a close enough metric for whether they are close to one another or not. But there can be a scenario, like when the logic is similar, but there are certain differences in the identifiers. Semantically, they are a little different from one another, but logically they are same. So how do we find out those kind of similarity, or how can we find out those kind of contaminations? So another level of check that can be applied is semantic level, where first we take our in case of a code sample, we would take the abstract syntax, we would form a graph representation of our code, right? And once we would have formed that, then we can go ahead and split that representation into smaller chunks, which is n-gram, which can be chunks of length n. Once we would have applied the n-gramming, then we can apply a similarity on top of that. Now, taking the surface level score and then the semantic level score, and then doing some kind of math on top of it, which can be taking a max over those, or you can just do a weighted combination of those two, whatever gives you the right approach to find the contamination, and then you can find the contaminated examples. Now, this snippet is literally showing you so this is actually a code snippet from a study that has been done, which shows that some of the very popular evaluation data set that are used for assessing the quality of the language models, which are human eval and MVPP, those examples are really seen in some of the open source large training data set. This is really a serious matter, and this is what this study is actually showing. Okay, so this is, so this is just an analysis that this study did, where the evaluation or the test data set, as I said, are human eval and MVPP. They are literally just the evaluation data set for the code-based language models. And the training data set in this case are the popular, the pile and the stack data set. And it has been observed that these training data set, they have a significantly large amount of contaminations, as you would see here. And the top one score is really nothing but showing the similarity between the test and the training data set here. And there is a significant overlap, as you can see, which is why this is, again, a very, very serious concern, and it needs to be addressed. Okay, next, let us talk about, I'll switch gears a little and talk about tokenization. Now, what is exactly tokenization? So when we're talking about language models, we talk about training the language models on natural language. We talk about training the language models on code. We also talk about training these language models on tables, PDFs, whatever data set we have, right? Now, we don't really ingest these data as it is, right? As you would expect, in natural language, these data set appear in the form of text, but you have to translate them into numeric representation before you show it to the model or your machine. Why? Because any machine, any computer, they do the processing on numerics, not on text or any other modalities that we have the data present in. So to do that, what we have is, so for example, if you have this sentence, which is a Unicode character like emojis, maybe split, what you can do is, you can take this sentence, and what you can do, you can literally just split this entire sentence into words, right? And you can assign some numeric ID to each of these words, right? This could be one way of having a numeric representation of the data that we have, and then we can show it to our model. Now, do you think this is a feasible method? So no, the answer is no, and there are both pros and cons. But the con or the disadvantage of this is that there are lots of words. And if you have to form a vocabulary of all of these words, it would really explode after a point. And so this is not the right method of representing the data when you are actually showing it to the model. And if you go across the languages, the amount of the vocabulary will only explode. So what can we really do? How can we show the data to the model? So another method is, okay, let's just split these words or sentences into character levels. That way our vocabulary is contained. It will not grow much. It will remain small, but what will happen in that case? So as you can see here, and there are advantages and disadvantages both to each of these methods. In the case of word level splitting, what happens is, okay, your vocabulary might expand, but at least you are keeping or containing the contextual and the semantic aspect of what is there in the words, right? So character, or for example, this word split, we know what these words mean. And if we split them further to character level, it would become very difficult for the model to understand what really the word was, because it never learned the word, it only saw the characters. So these are the pros and cons of using just the word level or the character level. Also in the character level, the problem is the semantic aspect is not present. So how can we make sure that we show these data to the model in a manner that we are computationally efficient, meaning that we have a small contained vocabulary, yet we are capturing the semantic aspects of these data that we have. So one way we can do it is sub-word tokenization, wherein we are not splitting the most frequent words, but we are splitting the least frequent words. So that way we can basically, so there has to be a trade-off between these two. But the sub-word tokenization is what has worked the best so far. And in majority of these language models that you see, this is how the data is represented to the model. So in this figure, as you can see, if you have a high-level sentence, you would basically just assign a numeric representation to it. And once you would have done that, it goes to the language model for the next stages. So we don't have to talk about those, but what is going in here is basically sub-word. So as you can see the colors here, the entire word is not going, but the most frequent words are going together as one unit. So UN is going as one unit, IC is going as one unit, ODE is going as one unit, characters going one unit, so on and so forth. Depending on what was the frequency of those, we are splitting the sentence in that manner. Okay, so here I'm talking about one of the methods based on sub-word tokenization that has been used very widely across the language models and has proven to be successful as well. One of them is called byte pair encoding, and a lot of language models have used this method of tokenizing the data set, starting with BERT, GPTs, Llama, and so forth. And the basic steps in forming the byte pair encoding is that you first take your data set and do the basic level of doing the word level frequency counting. Once you would have done that, then you go ahead and then each of the words are then split into characters, and then you look for the frequency of the pairs of the characters that are, and anything that is very frequent, they are merged together. Those that are not frequent, they are kept as it is. And this process is repeated until you would have reached some limit on the vocabulary that you have set, because you can only, so there are two things that we're playing here with. One is the quality of the data, another is how much compute resource we have. So here we will limit our vocabulary to an extent that we can afford, and we can't go beyond this. So typically the length of the vocabulary that you would see in the language models do not go beyond 32,000 to 64,000. Okay, so here, this is just an example that shows what I described, which is that if you have a training set, you split it into character levels, you take the frequency as the pre-step, like the first steps, and then from here on, you keep on merging the most frequent pairs together until you would have reached some limit with respect to the vocabulary length that you can fix to. Okay. So here, there are also some other type of tokenization methods, but less frequently used. They are, yeah. Okay, now, this is here, I'm just talking about one of the problems that you can encounter with the method that I talked about. So it is possible that, okay, even if we have formed the vocabulary, there is possibility that during test time, you may come across one of the words that was never seen when we were forming that vocabulary. So in this case, if you have mug, but UG was seen before, but M was never seen. So what would you do during the test time? Typically, there is some a special character, which is called UNK, which is unknown, that you fill it with. But as you can expect, it can result into uncertainties and losing a lot of information. Now, typically, this doesn't happen for large models where you have really large vocabulary, and chances of coming across such unknown variables are really rare, but this can occur, and this is one of the challenges. Okay, now I'm going to switch gears again and going to talk. So far we talked about filters that applies both on natural language, applies on code, tabular data, PDFs, and any other modalities that you can have with respect to text. Now we also care about the code we write, right? Because we have softwares everywhere around. We all write code. So we need to address the problems that we see with respect to the code data that we are using to train our models. So from here on, we are going to talk specifically what kind of filters needs to be applied on code data set, and why they are problematic. Because so we write code, and everything that we have seen on the internet with respect to the code, which is coming from GitHub, we are using that to train our models. And not all of those repositories follow some standard. Not all of those repositories follow style. Some of them are written by students, some are written by industry folks, and so on and so forth. So they may be of good and bad quality, and we really need to have standards with respect to filters that we want to apply. And they need to be generic enough. So we have at the end of the pipeline a data set that is clean and high quality, so that our models learn what is best practices that you would want to do with respect to software development and code writing. Okay, so to begin with, there are certain filters that we that the literature in the body of the code language model development have used, as well as we have come up with some of these filters. Now, programming language selection is one, right? Like when you have every kind of code repository scraped from the internet, you would imagine that they would have the code from every programming language. But if you want to develop the model, only let's say that is an expert in Python, then you want to make sure that your first filter needs to be the one that very accurately filters out all of the Python language code from the data set that you have. So that is the first filter. Second, as you would imagine, any code repository that you see in the GitHub, they have some kind of license associated with it. And these licenses are nothing but restrictions on how the software or the piece of code that you have in front, how can they be copied, modified, and redistributed. This is especially essential because some of these code can give you permissions for, let's say, copying and modifying, whereas on the other hand, some of the code may not give you these permissions. And this can be an issue with respect to, this can only percolate further into lawsuits and those kind of major issues, which you want to avoid. So it's better to have these kind of filters in place and only work with code that gives you the permissions to do what you really want to do with them. Okay, third one is malware detection. A lot of the code bases that you have from these repositories, they may not all be, there may also be some executable files, there may be non-code files, and it is possible that there can be viruses or trojans associated with them. So how do you detect them? You need to make sure that you filter those out as well immediately at that point in time. You can do that. There are lots of tools available for doing those. And we are also using, you can use any of those. We also rely on one of those tools to immediately just filter out those malware from there. The fourth kind of filter is alphanumeric filter. So what it does is, there can be certain code snippets which really has long non-code comments, which, as you can see in this code snippet, this is really not useful. It is a very long-running comment, which you really do not want in your final data set because it doesn't have a lot of logic but huge amount of, so 90% of the comment and literally just 10% of the code. So we want to get rid of these kind of code files because they don't speak loudly with respect to the quality of the data set. Okay, so the next type of filter we talk about is auto-generated filter. So this is not, so what happens in certain kind of code snippet is, now that we have ChatGPT and Llama models everywhere around, so it is also possible that they may be automatically generating code, as well as there are certain tools that generates code or intermediate representations. So what you would see is in certain kind of examples, you would see a header that says that this file is automatically generated. Now, this statement in various styles can appear in your header, and it is important that we just get rid of these kind of files because these are not human written code. So we may not know what really they represent in the body. And if we do not have a tool that further investigates into those kind of logics, it is easier for us at least to look for these kind of examples and just filter them out right away, which is what we are doing here. So if you look for certain keywords such as auto-generated, automatically generated, generated automatically, and so forth, you just write a regular expression or use some tool that exists out there and filter out such examples. Now, another kind of filter can be those where in the code snippets, you see encoded data in the form of, variables having hexadecimal representation or Unicode, so forth. So again, it is okay to keep those, but they can also lead to some, some kind of issues as to the model doesn't, it has been also observed that the model doesn't learn a lot from these kind of representations because they are non-English text. And if your vocabulary is only English, your model will only learn so much from these kind of representations. So just filter these out. Okay, the next type of filters are removing any kind of examples that have HTML, JSON, or YAML content, because if they are long and they are long running, then what happens is they can be just a storage placeholder for data, and those are not the kind of logics that help model a lot. So if the length of those files are really long, let's say more than 500, then you want to filter those out because they don't have the actual logic in there. And then there are other kinds of files which are text files. So there are also like readmes, requirements, to-dos, and so forth. So you want to check for those, and if they are there, you can filter those out as well. Okay, so these are again another kind of quality filters that we have been working on in-house, which are mean line length. Now, as the term says, it talks about what is the average length of the lines in the code file with respect to the entirety of the code file that you have. And over some experiments, our team have found that if there are examples that have line length within, say, 0 to 250, then they really have good logic, or at least a good distribution of these examples is what we have seen. But if you cross this number of lines, then you may see a mix of good and bad examples, both. As you can see here in the code snippet, for one of the Python examples, when we looked at this example, which falls between 250 to 800 line length, we see that, so it has a long running variable initialization, and this is exactly about 90 to 95% of the code. So this is not really helping a lot the model in learning anything. So we really want to just avoid these kind of examples. So this is what is happening here. Now, what is the recommended length then? Now that length can vary depending on what language you have in front, and all of those then goes back to how much standardizations have been done in the language. For example, Python has a lot of, or a gigantic library, or it is super extensive as opposed to C and C++. So you would see a lot of, you would see the line length, average line length in C and C++ is much higher than Python. So you need to fix those thresholds accordingly. Okay, next we are talking about character to token ratio. Now, why is this important? Now here, characters are really literally just the characters from the strings or the samples of code that you have, but tokens are the representation which we have translated the input raw text into. So why is this important to look at character to token ratio? It is because it speaks about the density of information that you are feeding to the model. Because there can be non-English text, as you can see in this code snippet, and the non-English text, because those were not seen in our vocabulary, they would be represented differently because our model never saw those. So it is possible that, so you can have a different character to token ratio in that sense with as opposed to the character to token ratio with respect to the English and any known vocabularies that the model has already learned. Also with respect to non-verbose code. So all of these factors come in, and this matrix will literally help in figuring out any non-code examples, any non-English text, a very verbose code, and so on and so forth. So this is Oh yeah, and this literally this non-English code snippet that we were able to filter out, it fell in the character to token ratio for higher than 0.5. Literally, if it is less than 0.5, then it would fall in the good category of examples. Okay. So this is the next type of filter, which is called personally identifiable information. This literally talks about all of the sensitive information that get passed into the data set that is fed to the model. Now, with respect to the code data set, as you would imagine, this can be with respect to the names, the username, any email address that was left in the code, or IP address that was left in the code, or username, password, so on and so forth, as you can see in this code snippet. So these are not good because, as we talked about in the very beginning, the models are very good at memorizing. So it is possible that the model will literally just memorize your password if you leave it in your code snippet and train your model on that. So you want to avoid those scenarios. So the way we can do it is, again, you want to either replace those existences, or you can remove those completely, those examples. And there are methods to do that. For example, there is a tool called Detect Secrets, which does that, as well as there is a paper that has regular expressions for IP addresses, emails, and so forth. Okay, so so far, yes. So this is all of the filters that I wanted to talk about. Now I will hand it over to Hima, who can talk about the semantic ordering of the code files, and she will also conclude with what is the takeaway from our talk. Thank you, everyone.
Thank you, Shailaja.
Thank you, Shailaja.
Okay, so the next thing that we want to talk about is pretty interesting. I'm sure all of you must have studied graphs in your computer science courses. We want to talk to you about how graphs can be useful as you think about LLMs and code data and how do you feed code data into LLMs, right? So here is a research question that we had at hand. How should we show the files of a repository to an LLM, right? Okay, so if you are if any of us who looks at GitHub repositories, right? How do we read code files, right? Okay, we read the README, and then we say, okay, this is the driver function. This function is this file has a bunch of these functions. This function is called in another file. Okay, let me go and read the code there. Okay, now this is calling the third file. Let me go and read the code file. That is how all of us as humans, typically we read files. Now we want to do the same thing for an LLM. We want to show the files of a repository to the LLM in such a way that we're not just showing random files, right? Code files in a repository, they have some inherent dependencies, and we want to exploit those dependencies to show them to an LLM, right? So that was a research question that we had at hand. So how should we show the files of a repository to an LLM? Okay, and why do we want to do this? For two reasons, right? To enhance the LLM learning, right? Because like humans, right, if you show the the information in an organized format, the LLMs have shown to learn that better. And the second is it also enables LLMs to perform repository level coding tasks. Okay, what does that mean, right? So you guys may have played with LLMs like ChatGPT, where you say, okay, write Python code to generate Fibonacci series or something, and it would write down some code for you. Well, that's great, right? But what does a repository level coding task mean, right? That when you actually get into real world software engineering jobs, right, you're dealing with huge repositories and you're trying to build software, right? And more often than not, if you're going to make some change in the code in one file, there might be ripple effects all throughout the repository, right? Or you might have to, or for you to write some code in a file, you may have to call functions which are defined in another repository. So these are called as repository level coding tasks. And we want to make the large language models smarter on how to do repository level coding tasks, which is actually the real jobs, and which is where they can provide maximum value to a software engineer. Okay, so what did we do? If you could go to the next slide, please. We brought in our concepts of graph theory from computer science to take care of this research problem, right? So the input to this algorithm is a GitHub repository, right? Any GitHub repository that you could think about. The output is ordered code files, right? So if we can just go back to the previous slide for a minute, please. What do I mean by ordered code files? So let me just give you an example. If you see on the right, this is data from our own repository. And you can see that there are two files. There's one file called data_process.py. There's another file called run_sampling.py. Now, data_process has a definition which is called process, which is doing some things, right? And now this definition, this function is now called, when you run _sampling, you have another function called get_samples. And get_samples, as you can see on the blue box on the right-hand side, calls the function called process_data. So it's basically calling the function which is defined in this file, right? And this is very common, right? If you're following good software engineering practices, this is a very common scenario to see. So what do we want? At the end of what is our expected output? Our expected output is such that we have the files in a certain order in such a way that the files where the function has been defined, in our case, right, process_data is defined inside data_process.py. That is shown first to the model. So if you look at the output and if you look at the fourth line, you can see representative sampling data_process.py, followed by the file which is called as run_sampling.py. So net, what have we done here is that we have ordered the file where the function was defined first, and then we have brought in the file which is calling this function, right? This is what we want to get at. So if we go to the next slide, we will discuss about how did we build this algorithm. Okay, so like I said, right, very interesting work with graph theory. What we basically do is we build a dependency graph G between all the files of a repository, right? So a software repository could have many code files, right? Every code file has some import dependencies at the top, right? Where you say from this, call this, or right, import this, and so on. So utilize the import dependencies, right? And we find the connections between the different files. And how do we represent everything as a graph where every file of a repository becomes a node, and there is an edge between two nodes if there is a semantic dependency between two files, right? So, and this semantic dependency is captured by the import dependencies, right? So this is how we form a graph right? So if you have a repository that has 100 files, you're going to have 100 nodes, and you're going to have edges between these nodes wherever the files are related to each other. And then we, remove the cycles so that this becomes a directed acyclic graph. A directed acyclic graph gives us some nice properties so that on a directed acyclic graph, you could perform a topological sort that would get you an ordered set of files very close to the example that I just showed you on the previous slide, right? And what we did was also we decided that README and other documentation files are placed at the top, because that's how, our intuition was that that is how humans understand the data. You'd look at the README first, try to understand what's happening in this repo and so on, right? And what I'm showing you on the right is actually based on this method, we actually trained our full big, LLM. And you can see that whenever on the right hand side on the table, you can see that when the LLM is trained with data in such a way that the files which are meaningful, they are placed together. When the LLM is trained with this data versus not, we have seen an absolute gain of a huge number of points. And you can see these are results from a popular evaluation benchmark that is called as repo bench. And what you see is the absolute gap for the Granite 3B code-based model 128K. 128K is the context length, and this was the model that was trained with this kind of data, right? So the net point here to understand is that the semantic data ordering of files improves the model performance and is also very useful for long context training. And we have placed a reference paper that talks in detail about this method. So if there is interest, you guys can go and look at it. Okay, if we go to the next slide, we are now coming to the tail end of our talk. Couple of things that I and Shailaja wanted to leave you guys with. First is, high quality models start with high quality data. And we have discussed a large number of techniques that help you produce high quality data. So we cannot stress this enough that, importance of the data and how useful the data is to build a high quality large language model application. Data preparation is challenging and time consuming. We have seen that. And we've also seen different downstream applications require different unique data processing approaches. And then there are also challenges, right, that get amplified if you have different modalities. For example, if you have language modality, you have code modality. Shailaja talked about examples from both language and code modalities, and you would have seen that how some of these techniques are different, right? Whatever is applicable to code, for example, where we were trying to get rid of bad code files, they're not meaningful for the language modality and so on, right? So we want to introduce to all the students an open source project, right, which is known as Data Prep Kit. You can scan this scanner code. It will take you to the repository. Let me just try grabbing the share for a second, Shailaja. Okay. Okay, so if you scan, you're going to reach to this page. Here is what I would recommend, right? Two things as students, right? And also here is a trick that's going to help you with your quizzes, that you're going to find a lot of the answers in the talk as well as in this repository. So I would highly recommend for you to go and bookmark this repository. For GitHub repositories, a standard way to bookmark is to, go and, star it. That way you can, when you open it, you can see it very quickly. So go ahead and start this repository. And what I would also encourage everyone is that if you are new, right, to open source community and development, the way to go, right, and understand is to go to issues, click by label and say good first issue, right? And go and read through some of these good first issues and see that is this something that you can contribute to as a student, and maybe this would be a nice thing right, to do as your class project or so on, right? So you could look and read through some of these good first issues that will give you some idea of what are the other open challenges in the data preparation space that you as a user could help out with, and that would also be a great way for you to get hands-on and learn about it, right? So in our next two upcoming sessions, we are going to do hands-on sessions with um, one, helping you understand the code, how to navigate this repository, and how to run some of the data preparation techniques that we just discussed today. And second is that, if you go to transforms, these are all the data preparation steps that are present today, right? But if you want to put in your data preparation module here, right, there's a very easy way to do it. And we want to teach you of how you can do that. That way you can make a real contribution while you are still studying. With that, we would stop here and happy to take any questions or any comments, so on. Thank you so much, everyone, for your time and your attention to this session.
Thank you, Hima, and thank you, Shailaja. It was a wonderful session. Participants, so we hope that you did make the best use of the very first session of the series. So since we are running short of time, what we would do is, I would quickly share the quiz link. The link has already been posted right through the session, so I hope all of you are ready. I'm going to share the screen. All I require you to do right now is, don't be in your Zoom screen, leave the Zoom screen, click on the link and go to the Slido screen on your browser. So I hope the instructions are clear. Kindly click on the link, the Slido link that has been provided. Robin and others from the PMO office, kindly be alert to see if there are people who are requiring the assistance to the link now. Yeah, so please post the link again. Click on the link that Robin has posted just now and go to the browser. So on your browser, you're going to see a first question. I hope all of you are able to see what is the expansion of Pals. I'm just giving you a few seconds here. All the questions that are going to come is going to be a timed quiz. And then the response that we have received. Were you able to respond? I don't see. Okay, hold on. I'm not able to see the response. Yeah. Okay, 100% of you have said partner acceptance in learning and sharing. But then the right answer is, actually there is no expansion of Pals. Pals is as in a friend. So I'm moving on to the next question. Select the primary purpose of large language models. So the responses keeps varying. Now these two questions were just the trivia questions for you to, understand the tool. I'm moving on to the actual quiz. So I hope all of you have logged in. We just wanted to give you some time to log in into the Slido. Hence, we conducted just those two sample questions. Robin, I hope we have pasted the questions in the YouTube link also. YouTube participants, we request you to join as well. I'm just starting the quiz. Please be on your browser. The very first question, 15 seconds. You can be on your browser. Zoom screen will not work. You'll have to be on your browser to click your response. Only 317 people out of 1044 registered have responded. Kindly be fast. So 99% of you have said true. And the right answer is that 1%. We'll move on to the next question. Okay. And the right answer is false here again. 35% of you have only got it right. Moving on to the third. Good. 90% of you have got it right. Fourth question. These 705 participants have responded. And the right answer, C, 63% of you have got it right. Good. The fifth question. So you need to be a little quick in answering. Memorization is the right answer. 21% of you have got it right. Sixth. Option B is the right answer. Moving on to the seventh question. Good. Option B is the right answer. The last question for the day.
Should I go for class? Should I skip? Please.
Okay. And the option A is the right answer. Good. Now you can come back to your Zoom screen. So congratulations, Tarun J. I don't know which college you're from. Then we have Shreya Rao, Munisha, Paladugu, Philo, and Anudipti Bocha. So all of you have been in the top, the top leaderboard with 7 questions out of 8 in 1.13 by Tarun. So congratulations. It is a good practice to append your college name so that you can get the due credit whenever along with your college name. Good. And we have few questions already, Hima and Shailaja. I'll just share the screen with you. You're able to see my screen?
Yes, you can see your screen.
Yeah. So you can answer, and meanwhile, if there are any more questions, we will, take it.
Yeah, so I'll take the first question. The question is, why are we using Jacquard similarity and why not cosine? So there is no hard and fast rule to what similarity do you really want to use. But if you look at Jacquard similarity, it's the reason why would you choose Jacquard is because it is looking at the similarity in a more fuzzy way, right? Like you consider the two examples as two sets and you look at the maximum overlap, which would be missed if you are doing cosine similarity, because you might not, again, you might in the cosine similarity fall back to the problem of exact similarity problem. So Jacquard which is why Jacquard wins over cosine in this case. But again, this is a very debatable question, and the similarity which works really well for the kind of examples you have in front, or the type of duplicates you really want to capture, is what you would really care about. So Jacquard, in broad sense, it's set based, so it kinds of looks at the overlap, so you can set a threshold and say, okay, so this is the amount of overlap I really want to care about, so I can just go ahead and try this out. But no restriction on even trying cosine similarity. It's just that it would fall a little closer towards the exact similarity scenario, so you can avoid that if you can. Second question is, actually I see a black screen. Okay. So the second question is, to capture semantic aspects of token, shall we go with n-gram tokenization? If we so, how can we limit n? Again, I talked about this already. So when we are talking about token, we care about how do we want to split the data, how small a unit we want to get to, because then it falls back to the amount of computation our model will have to do during training. So even if you are considering n-gram, you need to now, again, this n-gram is going back to the scenario of character or word split or sentence split, right? Because you're only changing the length of n here. So I will go back again and say the one method that really worked well is sub-word tokenization. If you go for n-gram tokenization, here I'm believing you are thinking about sentence level splitting, right? So you would have certain number of words as tokens in this case. So it may work well, but if you consider a token with more number of words packed together as one token, then you can think about it. It will translate into having more computational cost, right? Because one token has much larger length, as well as your storage cost is going high here. Because previously, if I'm considering just sub word, then it might be taking up, say about 20 or 25 bytes to store that token, as opposed to when you are having 2 or 3 words in that token, where you might be now expecting to have 200 or 300 bytes per word. So all of these is translating back into the amount of computation you would have to do and storage costs. As well as, again, the quality will be the third dimension. So this is what the answer would be. Third is question. I need to integrate real-time feedback loops in the LLM training process, allowing for immediate adjustments in data quality and model parameters during training to enhance performance and reduce the time and resource required for model optimizations. How would I approach it? So there are many methods. When you're talking about feedback method of making the learning progress for the language models, there have been a lot of method. So one of the method is here, which is called proxy policy optimizations. And along those lines, there have been a lot of methods, which is called DPO, PPOs, reinforcement learning with human feedbacks, and so on and so forth. So this is one dimension, right? In this case, what you are doing is you are literally having your language model taking the feedback from the human and feeding it back. So in this case, you are actually penalizing or incentivizing your model while it is training. So this is happening during training. But your question also says, yeah, so this is typically during training. So this would be one of the methods in which you can tweak the weights of the parameters of the language model. And this is one way of making it learn. The other methods that people have come up with is, we also had one question on that, which is a RAG, retrieval augmented method. So that is not the training specific, but basically more like a fusion of both the worlds, where you already have the models trained, but you take multiple models here right now. So you can have single models specialize in specific tasks, and you can just put them all together and do in this case also you can do but this is more like not pure training. This is more like training and training and inference. So yeah, so I think your answer to your question is basically doing RLHFs or DPOs or PPOs to have the feedback addressed when you are doing the training.
Let me just add to that, right? So if you're just purely thinking about training and not really the whole inference loop, right? The other thing to think about is that as you're training, you can monitor the loss, and wherever the loss fluctuates, you can map it back to the batch of data that was fed, which caused a high loss. And it is highly possible that in that batch of data, there might be, I think there might be some different type of data, or there might be some bad quality data, right? So that could be another indicator for someone to improve data, or at least get an insight of where bad quality data might be affecting the model when you are purely talking about it from the training, during the training stage, right? But like Shailaja pointed out, if you're thinking about training inference and the whole feedback loop, all of this RLHF and all of those will be super, super helpful.
Yeah, and I think one thing I'll add to that is there is another method I forgot to add, which is called model distillation. That is another method to make the model learn from feedback. Now, the feedback in this case is not coming from human, it is coming from a more expert LLM. So basically, you can take a very large model, which is an expert in everything, and you want to now learn a smaller model. So you can consider your larger model as your teacher, and the smaller model is a student model. So the student model keep taking feedback from the teacher model in the form of either outputs or in the form of weights or loss, as Hema said, while as a feedback, while you are learning from this teacher model. So this is another distillation method of learning where you can use feedback. So there are a lot more methods in the literature, but these are very popular methods that are used in the day-to-day method of training. And
yeah, the first two questions were from Dr. Yamunatangam from Velalar College, based out of Erode. And he has a follow-on question. He says, shall we combine RAG and RLHF?
Yeah, why not? But depends on what do we really want to
purpose?
achieve. Yes, the question is what do we really want to achieve, because both have their own pros and cons. So when you are considering RAG is literally a solution for when you have, a lot more context that needs to go in the input, right? Like, so sometimes with the question, we also want to feed the entire PDF, let's say the entire paper that we have. And these models, some of these may not have the capacity to understand everything, or even having that limit to include everything that is coming from the inputs. So if you have RAG, then it can basically, take your large papers or your PDFs. It can get an embedding for that particular large input, translate it into an embedding form, which is much more smaller and fixed size, and something that the model understands, and you feed it. And you can do this for n number of such contexts that you want to include in your question. So RAG fits for this problem. But RLHF now solves our problem of, how much do we want to align our response with respect to what is expected. So the feedback is basically helping us align our response towards what we expect as an answer. So this is the objective for these two chunks. If combining these two solves the purpose, then yes, why not? Does that answer the question?
Yeah, I tried to unmute the participant who asked, but he's probably not able to unmute. Sir, if you have any follow-on question, yeah, please do ask. Any other questions, participants? Because it's already 15 minutes past our regular time. Any questions?
Sujata, Mr. Pati had raised his hand.
Yeah, I did see. Mr. Pati, you have a question?
It was not for asking question. I wanted to be unmuted. Yeah. That is why I raised the hand.
I saw his messages in the thing. Yeah. Good. So if there are any follow-on questions, no harm. We will definitely take it up in the next session. Thank you so much, Shailaja and Hema. It was wonderful. I would now request Mr. Pati Lakshmi Narayan to conclude the session and give the summary of what we have learned today. Over to you, Mr. Pati.
Thanks, Sujata. First of all, thanks to Hema and Shailaja to make this session more interesting and passionate immediately after the lunch. And then it is really delivered with a lot of passion. And then I would like to definitely say big thanks on behalf of Apls as well as all the colleges who participated. Second thing is, more than 1,000 people participated for this program immediately after the long holiday, and then today is on the afternoon to attend this one. That really shows the importance and criticality of the topic for the students as well. So thanks for the people who joined. On behalf of Apls, I would like to thank both IBM, Hema Patel and Shailaja, as well as to the faculty and then students from the colleges who joined for this. This is nearly an eye-opener for me. And then I just started that award. Even though I know some basics of AI, I was not much aware of what are the work IBM is doing in this area. It is really an eye-opener that IBM is doing a lot of things in this area. And then the relationship with the Apls with IBM goes to 2020. I was talking to CNC. He was telling that a strong relation built over the period of time. And then we are having a lot of every year with colleges to make students aware of all the AI things what IBM is doing, and then make them kind of a techno-savvy in this area. So that is right. That is really good. And then these two people talked about methodology, how the data is important, and what kind of techniques are the duplicate table methodology, near duplicate, by example, data contamination, how we can avoid, what are the reasons, tokenization, and what is the best way to tokenizing, and then handling unknown words, how the unknown words can be handled when we are handling this model and then inputting the data. Then the code quality, what is the impact about the code quality and all, very well described. And then definitely following session, whatever you are going to have with the practice, will help the people to improve the knowledge and awareness about this IBM tools, methodology, and then how the data can be input efficiently. And then data is one thing just I want to add here is any model is good, but the responsibility of using the model is with the human. The human loop is very important when we are using this. What kind of data can be input is very, very important. So one of the example that may not be with IBM is when we are giving input for all the CEO and CXOs of various big companies, if the data what you are giving are all with say Americans or Europeans, there will be a lot of data discrimination there, and then whatever data we are fielding may not give the right answer because it is filled up with various people across the world, with leadership from Chinese, Japanese, Indians are there. So the data, whatever you are giving for various things, is having social responsibility. And then what kind of a data we can input? Definitely the hallucinations are to be avoided. So in that perspective, I would say that this is a very good topic to start with. And then whatever is presented is very interesting, even for a person who is very novice to this kind of a session. Thanks for the same. Looking forward for the practice session and then remaining sessions from IBM. Thanks to you again, Shamala, Shailaja Thakur and Hema Patel. Over to you, Sujata.
Thank you, Mr. Pati. So, Kelita, do you have any words to say, or shall we conclude?
Can conclude. Just wanted to tell that both Hema and Shailaja, you've set the tone with this foundational session, and we're looking forward to the next two, especially all the resources that IBM is sharing, like the Google Prep Kit and others, for the benefit of our students and faculty attending the session. We're looking forward for the next two. Thank you for sharing your expertise and knowledge in these sessions.
Thank you, Kelita. Thank you, Dr. Kelita. So now a lot of you have, logged off of the session, but I would like to give a few important points. One is we will send you the feedback and the, if the material can be shared, we'll check with the IBM resources and then come back to you to share the materials also that has been shown in the presentation today. And we request you to take few minutes to definitely take time, reflect on what you learned out of the session and give your feedback. The feedback is not really for us to improve. It is also a reflection for you to know what you have learned. What are the key takeaways that you have got from the session today? So we will send the feedback link post this session. Meanwhile, Robin has also created a WhatsApp community group. All the information regarding the session and the next few sessions will be posted there. So we request all of you to join the WhatsApp group. Look out for mail communication from us. And then the next session is on Thursday, 29th, between the same time, 1:30 p.m. to 3:30 p.m. So thank you all and see you in the next session on Thursday. Thank you, Hima, and thank you, Shailaja.
Thank you, everyone. It was wonderful sharing our work and research, and we hope this is useful. And we hope that this provides an avenue for students as well as faculty members to contribute to open source data preparation area for LLMs. Thank you very much.
Thank you.
Thank you.
Thank you, Ram.
Thank you.
Thank you, Shailaja.
Thank you.
You can log off. Yeah.
Yeah, and I think, having 1,000 plus, and even the Slido quiz had 700 plus take each question, right? So that also shows that people were attentive. during the session. So it's a great start. So thank you, Sujata, Robin, both of you for organizing everything. So see you at the next session.
Thank you, Gurita.
Bye, Ram.
So participants who are having attendance problem, you can chat with us quickly and get it sorted now. I mean, during the session, it is impossible for us to keep attending to your individual questions on the attendance. That is not of very importance at that point in time for us. We wanted to ensure that the session goes on well. So if any of you are having attendance issue and have not been able to sort it now, you can talk to us. I will allow you to be unmuted. Just give me a second. Yeah, you can unmute and speak now if there are anybody who has problems.
Ma'am, I don't have any doubts, ma'am.
Bye, Dharani. Take care. You can log off the session, not a problem. Mukesh Krishna, what is the problem that you have with the attendance? Can you unmute and speak? Logeshwaran, I am present, but the attendance is not registered. You have been given the attendance link. You have to just mark your attendance. If the attendance link says you have not registered, you have to register and then mark your attendance. That is the process. Shivaranjani, I mentioned it to you very clearly. Feedback link will be sent as a mail. You can log off if you have marked your attendance, Shivaranjani. So if there are no questions, then we can, exit the meeting. Thank you all. See you on the 29th, Thursday. Make sure to log in 10 minutes early. Thank you. Bye, Robin. Take care.
Thank you, ma'am.